All right, so on the review for topic 3, very first question, what are the properties of the 4 types of rigid motion? So there are 3 main ones, but then this also includes the one that combines 2 of them. So we have Translations, rotations, reflections, and glide reflections is the 4th if you couldn't think of one. So again, it is considered to be a rigid motion. So that would be our 4th. All right. So if you could only think of 3, there are really 3 main transformations that are rigid motions or congruency transformations, but glide reflections also counts as a 4th type of rigid motion. All right. On the next part of this, you had a word bank. So on number 2, a blank is a transformation about a point with a given angle measure. So that would be a what? That would be a rotation. So rotation. So you're rotating a certain angle measure. Reflections, translations, rotations, and glide reflections are 4 types of, hey, look at that, rigid motion. So it's kind of the same thing as question number 1. Rigid motion. On number 4, a line that a figure is reflected across so that it maps onto itself is called a... So that one was kind of tricky. And line of reflection was there as a choice to kind of throw you off. It is line of symmetry. So the key word there is that the figure is mapped onto itself. Again, if you see the words mapped onto itself, that is specifically talking about symmetry. All right? So if a figure is mapped onto itself through a transformation, it is symmetry. Now, because if it were to reflect across a line, it's not going to map onto itself. It's going to map an equal distance away from the line, right? So, yes, there is a line of reflection where the line of symmetry is. However, specifically if it is mapping onto itself, line of symmetry is what you should be talking about. All right. The composition of a reflection and a translation is called a glide reflection. Now, glide reflection. All right. The set of points that a transformation acts on is called the preimage. Yeah. So, again, preimage is the original, image is the new. The result of a transformation is called the... So this is the other one, this is the new one, the image. Now, I might put another example here just to recap this because we've been using it a lot throughout the chapter, but we haven't talked about it a lot since the first few times. But again, it keeps appearing, so I just want to point out. If the original preimage was ABC, the image would be marked as A prime, B prime, and C prime. Remember, the primes tell you that it's the image. All right. So now, number 8.
Wait, can you go back up?
Again, I'm going to post the pictures of this afterwards online as well, guys. So, on number 8. Does the transformation appear to be rigid motion? So, does that one look like that one? Yes. It looks like it stayed the same shape. It looks like it stayed the same size. It looks like it's just been rotated. Therefore, this would be a rigid motion. So, yes. And if you want to be specific as to why, because it has been rotated. You could also say same shape, same size. All right, same shape, same size. All right, I kind of went off the paper there. All right, on the next one. So they gave us points, and it said, these are the vertices of H, J, K. What are the coordinates for vertices H prime, J prime, K prime for each reflection? So for number 9, I'm going to go ahead and list them over here. We're going across the x-axis. So again, you need to know 3 main things just based on points. The x-axis, the y-axis, and the line y is equal to x. Also, remember, I could ask y-axis as, instead of saying y-axis, the line that is x equals 0, because that'd be the same line as the y-axis. And the x-axis would also be y equals 0. So again, keep those things in mind. You'd have to be able to recognize it either way based solely on points. So, for this, each one of these, going over the y-axis, which value changes? The x. So, 3, 2 is now going to be at, I said 3, 2. I read off the correct point, sorry. Negative 3, 2 is now going to be at 3, 2. So, we change the x value of that point. For J prime, again, was at negative 1, negative 3, so now it's going to be at positive 1, negative 3. Again, only the x value changed. For K prime, and 4, 3 will now be at negative 4, 3. So again, only the x value. For number 10, going back to the original points, now which value changes? The y, right? So, now H prime would be at negative 3, negative 2. J prime would be at negative 1, positive 3. And K prime would be at 4, negative 3. Just to remind you guys of the other line that we sometimes will have reflected across, the line y equals x, the x and y values do what? They switch. So if y equals x, they switch places. All right. 11 I did not ask you to do. All right. Number 12, which is on the next page. So, for 12 and 13, the vertices of P, Q, R, and are given here, P, Q, and R, at those points. What are the coordinates of the vertices of P prime, Q prime, R prime for each of these translations? Now again, when you're given a vector, all you're doing with that vector is adding those values to the original. Now, remember, you should know how to do it in this notation. You should also be able to recognize it in the other notation that looks like this. X minus 3, y plus 2. Whereas this one would be x comma y gets moved to x plus 4, y minus 5. So again, you should be able to recognize in that notation as well. So the actual points, there's not a lot of room here. I'm going to write it right here down the side. So P prime, Q prime, and R prime. So we're subtracting 3 from x, and we're adding 2 to y for the first one. So negative 3 minus 3 is negative 7. 3 plus 2 is 5. So negative 7, 5 would be our point. For Q, negative 2 minus 3 is negative 5. 3 plus 2 is 5. 1 minus 3 is negative 2. And negative 3 plus 2 is negative 1. So we have our points. P prime is negative 7, 5. Q prime is negative 5, 5. And R prime is negative 2, negative 1. For number 13, we moved in a different direction. So again, I'm also going to list those off to the side here. So this time we're going 4 units to the right. Right, so adding 4, and 5 units down, subtracting 5. So going back to the original points. Negative 4 plus 4 is 0. 3 minus 5 is negative 2. So that point is 0, negative 2. For Q, negative 2 plus 4 is positive 2. 3 minus 5 is negative 2. So that point is 2, negative 2. R, again, 1 plus 4 is 5. Negative 3 minus 5 is negative 8. So that point is 5, negative 8. So again, P prime is 0, negative 2. Q prime is 2, negative 2. And R prime is 5, negative 8. So that was for number 13. Number 14, they want to know what translation is shown below. So, first off, we know it's a translation because it's facing the same direction, right? So now, they also told us on this one it's a translation, so we should be able to identify how many units over and down it moved. Again, I like doing left and right first, since all the notations that we have usually list it first. So it's going this way, and then this way. So we're going positive 1, 2, 3, 4, 5 units to the right. Oh, thank you. So we're going positive 5 units to the right. And then we're going 2 units down. So negative 2. Again, there were several ways that you could write this. Translation of 5, negative 2 in vector form. You could write it as x comma y is moving x plus 5, y minus 2. You could also say right 5, down 2. Number 15. Make sense and persevere. Oh, we didn't do that one. All right, moving on then. Any questions there before I change that? Okay, for number 16 then, so that's on the next page. Again, I will post these online. So on number 16, we have a rotation of 90 degrees around the origin. Oh my god, they did that backwards too even. You know, this book sometimes. But 90 degrees around the origin is what they're trying to say there. So, what we should know, again, I'm going to write this in the other notation for just a second. So, how does x and y change because of this? Oops, I put the wrong thing. Those are supposed to be parentheses. My bad. Alright. We are switching the x and the y becomes negative. The original y. So it's negative y, comma, x. If we go positive 270 degrees, again, they will be switching. But now it's the original x value that's the negative. Yep. If we had went 180 degrees, what would we have done? X and y would have stayed in the same place, but they both become negatives. All right. So again, be familiar with those notations as well. I will have you match some notations together. So again, I'll give you one of the formats that we've done, and you have to match it up with some other notation that we've done. So you have a set of matching like that, where you have to match different types of notation. All right. For each of these, so we have our points that we have to rotate. I'm gonna write them down right up here in this empty space. So for number 16, we have A prime, B prime, and C prime. A prime, again, we are switching this and making the original y negative. So since the original y is already negative, it becomes positive. So this will be at positive 2, positive 2. This one, again, the original y was already negative, so it becomes positive. So positive 2, negative 3. On C, again, switching them. This time, the y value was positive to begin with, so it becomes negative. Negative 3, negative 1. For 17, same type of idea here. Like I said before, that's a B. Like I said before, it's the original x value that's become negative, and you're switching them. So the x value here was positive 2, so it's going to become a negative 2. And again, we got to switch them, so negative 2, negative 2. On this one, again, the negative 3 is going to become positive, and we switch them, so we have negative 2, positive 3. The original x value was negative, so it becomes positive, and we have 3, positive 1. Now, could you draw those on a coordinate plane and rotate it? Yeah. Again, some problems I'll give you a coordinate plane for, some I won't. Could you always just decide to draw one if you needed? Yeah. So again, if you need the coordinate plane, then draw it and rotate it. All right, so that was 16 and 17. The next ones I asked you to do was 22, which is on the next page there. All right, glide reflection. Now, if I asked you to do something with a problem like 20 or 21, I'm not going to give you crazy lines like they do up here. I would make it so that you're doing multiple transformations only using the regular lines, like an x-axis or things like that. Or if I did make you do it over something else, I'd give you a diagram of a graph. I wouldn't do it just based on points. This is way too hard. All right, on number 22, what is a glide reflection for the transformation shown? So, let's see, how did it move? Well, if we look at Q went down here, right? S went down to there. So we can picture this. It would have looked something like that, right? How many units down did all these points move? So it's translated down 5. Again, there's many different ways that you could write this, but translated down 5. And then we reflected it. Where did we reflect this one? So this one was a little tricky. So if I look at the Y, I wasn't quite over the Y because this is only 1 unit, this is 2 units. They have to be equal distance away. So this one was tricky. The midpoint of these two would have been right at a half. Same thing here. This would have been right at a half. So it would have been across this line at x equals a half. I'm not going to give you something where it's at a half unit on the test. But again, this is being reflected over the line. X equals 1/2. So again, a little bit tricky on 22. I'm not going to make it that hard on the test. Yeah. No, so could you have went into the reflection first and then the translation? Yeah, so we could have switched these around. Again, glide reflection is the only one out of the compositions that can be switched. All right. Okay, 24. Describe the transformation that can be used to map the figure onto itself. Again, keyword there, map the figure onto itself. We are talking about symmetry, right? Anytime you see it talking about being mapped onto itself, that is specifically for symmetry. That's probably the reason I keep referring back to those words so that you don't make a mistake on the test. So again, symmetry is the only time you're going to use the words mapped onto itself. You won't use it for anything else. All right. On here, what types of transformations could we do to show symmetry here? Reflection and rotational. So if I drew a vertical line down here, we'd have symmetry, reflectional symmetry. Or if I did a horizontal line, we'd also have reflectional symmetry. Or if we rotated this, how many degrees is that? That's 180 degrees. So we're going to talk about, again, there's rotational. There's reflectional. Reflectional. Now, you could talk about point symmetry as well on this figure since it has a rotation of 180. But based on what it's asking here, describe the transformations that can be used. Again, we're only going to talk about reflections and rotations. We don't have something else to describe the point symmetry. But there is point symmetry since there's a rotation of 180 degrees. Like I said, the first time I talked about point, I will not throw point symmetry on the test. All right, it's not there. All right, 25 and 26. Describe all the symmetries of each figure. If the figure has reflectional symmetry, identify all the lines of symmetry. If it has rotational symmetry, give the angles of rotation. So, on this one, is there line symmetry on this one? No. Yeah, there's no way that you can do that where it has line symmetry. Is there rotational symmetry? Yes. So, if I took this and rotated it around to this point, something like that, it's what? 180. Now, since there is rotational symmetry of 180, there's also point symmetry. So rotation symmetry of 180. Oops, I should put symmetry there. Rotation symmetry of 180, and there's also point symmetry, because anytime you have rotational symmetry of 180, there's point. Again, I'm not going to ask you the point part on the test. All right, on this one, if I rotated it, does this one also have rotational symmetry? Yeah. What's the angles there? 120. All right. Again, you can rotate it 3 times. 360 divided by 3 equals 120. So again, it has rotational symmetry of 120. Does it have reflectional? Yes. It has 3 lines of rotational symmetry. Sorry, reflectional symmetry I meant. Reflectional. And again, 3 lines. I'm doing all 3. Alright, 27. Suppose a figure has at least 2 lines of symmetry. Explain why the figure must have rotational symmetry. So, if it has 2 lines of symmetry, it has 2 lines of symmetry, saying it must have rotational symmetry. Anybody give me maybe an example of something that would work for? Just a basic example, doesn't have to be anything great. A plus sign, alright? Let's see. If I do a plus sign, let's see. There's at least 2 lines of symmetry. Oh, thank you. If I do a plus sign, I could draw. Now, this one actually has more lines of symmetry than just 2, but I drew 1 horizontal, 1 vertical. So, if you have at least 2 lines of symmetry in a figure, then we should be able to rotate it. If not 90, at least 180, right? If there's at least 2 lines of symmetry. So there will always be some type of rotational symmetry if you have at least 2 lines of symmetry. Now, if you have 1 line of symmetry, does it have to have rotational? No. Alright? And I gave you guys an example of that on the first day. An S. Wait, no, that was not the example. Hold on. That was the example of rotational but not line. What was the example of the other? It was... S showed rotational but not line. The crescent moon. The crescent moon, again, it has line symmetry, 1 line of symmetry, but not any rotational symmetry. Again, you have to have at least 2 lines to guarantee that has rotational. But again, if it has 0 lines of symmetry, that doesn't mean that it's not going to work with the rotational. So you got to be careful. Right? So that was kind of a hard question. All right. Moving on to 6 and 7. This was from 194, yes. All right. So, if figure A and figure B are congruent, wait, I think I read that wrong. Determine if figure A and figure B are congruent. If so, describe the sequence of rigid motions that maps A onto B. If not, explain. So, would you say A and B are congruent? Yes. All right. I agree. They are congruent. Yes. Congruent. All right. What could we do in order to map that onto this? And there was more than one correct answer on this one. Could you do a glide reflection? You couldn't do a glide reflection. All right. And you don't necessarily have to have two things. So I heard one. You could do a rotation. Oops, rotation. Or you could do a reflection. So, you could get this more than one way, because I could reflect over this line, or I could rotate it around this point and end up with that figure. So I could either do a reflection across this line or rotate it 180 degrees around that point, and I'd end up with that same exact image for B. So either one of those works. Don't have to do both, just have to do one of them. All right. What about A and B on number 7? Yeah, no, that's not congruent. All right. Why not? Give me a reason. It's a dilation, which means that we're going to change the size. So again, dilation, it comes up in a chapter later on. But again, the idea of a dilation is that the size is changing. Size changes. Again, in order for it to be a rigid motion, size has to stay the same. Again, rigid motion and congruence transformation, same thing. Questions? All right, I'm going to stop this. How much time?